Okay. Just to start off, the sky this month is actually rather boring because there's no real meteor showers. It's typically overcast. The eclipse was last night and it was glorious. Too bad, Laurel. Um, I saw it all. Uh, anyway, I will do my best. And I was talking to Dr. Mann about, you'll notice in here, I deleted the bit on that, the blaze star, as Charles called it, T Corona Borealis. But apropos of her talk about stars and supernovae and so forth, it's part of a binary system. And when I quoted it earlier as having a mass of about 4 times the mass of the sun and being a white dwarf, that's greater than the Chandrasekhar limit of about 2.7 solar masses, at which point it goes neutron star. So there's something a little bit amiss there. But apparently it's a carbon, oxygen, neon core. Helium and hydrogen, they're gone. And it's like 50 million degrees Celsius and roughly the size of the Earth, with a ferocious gravitational field. And its partner is going into the giant phase and doing this and blowing off its hydrogen, the outer atmosphere of the star, a lot of which falls into the gravitational well of this little white monster. Surface gravity that I read is 328,000 G. That's steep. Yeah. Well, you'll be flat. Okay. You'll be really wide and one molecule thick. And what they figure happens, it just builds up hydrogen more and more and more and more. And under those kind of pressures, and the fact it's 50 million degrees underneath it, eventually it fuses and boom. And the speculation is this will keep on going until it generates enough additional mass that stays behind on this white dwarf for it to collapse. And maybe you get a type 1A supernova. I don't know. But like I said in my last article, I just wanted to kick off before I do. Anyway, it occurred to me, we all know where Polaris is and what it is. It's within half a degree of the intersection along the line of Earth's rotational axis. And that's great for figuring out stuff because we use our Earth and equator and poles as the reference for everything we see in the sky. And when you try and visualize things moving around on the ecliptic, like the planets do mostly, that's tilted. And the North Pole star of the solar system ain't Polaris, it's up there. It's 23.5 degrees away. And I thought, I wonder where it is. So I got into it a little bit. Zodiacal light, and I have been assured that is how you pronounce it. It's like maniacal. So phases of Venus, because it's doing its inferior conjunction going between us and the sun. And then Saturn, too close to the sun, unfortunately, but its orbital, its rotational, its equatorial plane is going to intersect us this month. And then we get to look at the other side of its rings. So moving right along. I tried to figure out from Stellarium, okay, 23.4 degrees Polaris is here, so it should be 23.4 degrees due south of Polaris. And it took me about 20 minutes to realize I wasn't doing it right. And those of you who really know stellarium will be laughing right now. You can open the viewing options window and check the little box for ecliptic grid. Click that on. And if you look at this, there's two grid systems here. There's little lines that are a pale greenish color, I think, and they center right there. Wait a minute, where's Polaris? Where's Polaris? Polaris is there. This is the center, the pole star for the solar system. And if you look, well, there's some stuff in the way on the right-hand side, but you will see Mars right near Regulus, Castor and Pollux, and here's Mars, I believe. Jupiter, Saturn is right in there, and they all go around on this. There's the center right there, that red spot. And this star, come on, where's my cursor gone? There it is. That little circle there is a star in Draco, the dragon. There is no star right at the center, but I thought, you learn something new every day. But basically, if the solar system is like this, that spot is on a line orthogonal to the plane of the solar system. And it's tipped relative to the celestial sphere that we plot according to Earth and its pole star and its equator. And that's why it looks different. Or, as they say, read the instructions. One thing you may be able to see, I've never seen it here, but I've seen it a number of times in Hawaii, is the zodiacal light. And you see it best at the equinoxes. The spring equinox looking west after sunset, and the fall equinox looking east before sunrise, because then the ecliptic is tipped the maximum degree at the horizon to the equator. And if you look, this is, March 19th at 2041. And this glow here, it's sort of a triangle. It's very diffuse. Now, you can dial it up in stellarium. So I jacked it up by 3 times, and you see it as a sort of triangle. It took me a couple of times in Hawaii when I saw it there. You could see the Milky Way clear as a bell. And then here's this triangle. And oh yeah, that's a planet there and a planet here. And I thought, damn it, that's it. First time I'd seen it, well, I was 65. I thought, well, it's easy to see in Hawaii. I've never seen it here, but I'm hopeful. And all it is the gas and dust and little bits of stuff in the orbital plane of the planets. And it's lit up, because it stretches out in the same plane. When that plane intersects the Earth's horizon at these times of year, it's above the horizon, you can see it, especially if there's no full moon. So we'll see. Phases of Venus. I did a little bit of this last month. And if you can see the stellarium screenshot, it's a very, very thin crescent. But its orbit is tipped about it's not tipped 8.5 degrees, but on a line between us and the sun, Venus will be close enough, it's 8.5 degrees above that line, which means it passes north the line, and you'll see it in the evening, and the next morning you'll see it in the morning as it moves between us and the sun. And you can see the phases with binoculars. If you can get them steady enough, it's about the same view with a pair of 7x30 binoculars that Galileo had. Because a pair of binoculars you buy for $75 was, world class in 1610. And you get two for the price of one because they're binoculars. So this is the 16th, March 16th at about 8 o'clock. And that's what Venus will look like. It will be a little bit brighter than it shows up here because stellarium isn't exact. Come on.
Get a pretty good photo of that from the airport.
You probably would. Now, March 23rd is conjunction. And this is a stellarium shot of 6:48 in the morning. And you'll see it in the east as the morning star. And that's going to be quite bright. It'll be about magnitude -3. And it will be ahead of the sun far enough you'll be able to see it. So you'll see it in the evening and in the morning. And by the way, Venus is bright enough that if you know precisely where to look, you can see it in the daytime. Binoculars help big time. We had a conjunction of crescent moon and Venus as a crescent a few years ago. I didn't get a picture of it, but some people did. And with a pair of binoculars, you look at it, and here's the rim of the moon as a thin crescent, and right beside it, here's this little crescent of Venus, brighter. And I thought, this is why I like this sort of subject. Anyway, April 11th, which is, get out of there. April 11th is the end of this month period, and it will be well up in the east. That's 5 degrees right there. So it'll be 7 degrees at 6 a.m. And then it will be a morning star. It won't be a great apparition because it will be fairly low to the horizon because the ecliptic is tipped down at that point. Anyway, you can see the distance. It comes to about 26 million miles away from us on the 22nd, and it's almost 1 arc minute in size. That's 1/30th the size of the moon. Which, when you think about it, the moon's as big as your little fingernail, and you can see a disk that's 1 arc minute. You can see it as a disk. So that's Venus. And on the 23rd of March, its equatorial plane, we pass through it. It's on its way around the sun, and that plane goes through our orbit, and the rings are edge on. They're like 100 meters thick. Think about that. They're 150,000 miles in diameter and 100 meters thick, which is really thin. You won't see them. At times you can see their shadow on Saturn, I'm told. My scope won't show it, but it looks like a slightly flattened Jupiter, and it's distinctly fainter. when you can't see the rings because they're so highly reflective. So this is sort of Saturn at its minimum. Now, regrettably, it's only 10 degrees away from the sun. So you can't get a good view at this time. But some other time, another 15 years, we'll be able to see it go the other way. You will, I won't. But anyway, too close to the sun. And as they say, that's all, folks.